All right, so today we are moving on to lesson 7. So we're doing the same stuff. Now we're solving problems modeled with linear functions. So we're going to solve mathematical problems by graphing. So we're going to use a graph to help me solve. And we're going to solve and graph real world problems modeled with lines, linear functions, okay? I should sound like a broken record on repeat, okay? Because we're still doing the same stuff. Yesterday, our focus was on constraints, okay? What the limits were allowed to be. Today, we're going to focus on using the graph to help us solve, okay? I'm actually going to start on page 2. So go to this guide right here. So before we add words and context, let's first focus on just using a line, a graph already given to me to solve the function, and then I can start putting real world stuff to it. All right. So here we have a function 2/3 x minus 8. It is already graphed for you on the grid. We have a y-intercept of -8. My slope, it's going up 2 and over 3. Okay, I see it has an x-intercept of 12. It's all there. Okay. Number 1, use the graph to find the solution f of x equals -2 and label that point that represents the solution. So once we use the graph. If they say the function equals -2, did they give me the x or did they give me the y? The whole function equals a number. I heard it over here. It's the y. They've given me the y. So they've said, hey, if y equals -2, what does x equal on the graph? Is what they want to know. Okay, so if I look at my line, I find where y is -2, which is right here, right? Where is that going to be on my line? I'm going to go over. Looks about right here. What x value is that? Looks like it's an x value of 9. Okay. So that's using a graph to help solve. Boom. If y equals -2, I can see on the line that the x has to equal 9. Okay. And we've labeled that point. 9. We've graphed it and labeled it on the graph. All right, number 2 wants me to solve proving algebraically that my x value has to be a 9. So what they've done is they've already set up my function. They've made it equal to -2. Remember, this is my y. Equations equal y. They've made it equal to -2. So let's solve for x. We should know what we get, right? What should our answer be? It should be 9, right? Let's make sure it is. So what's the first thing we're going to do? Add 8 over. So now we have 2/3 x is equal to what? 6. Good. All right, we have 2/3 x. 2/3 is a fraction. Fractions are what? Fractions are division. So what's the opposite of that? Multiply. It's 2 divided by 3. So what are we going to multiply by? Multiply by 3. Okay, that gets rid of my denominator. Now we have 2x is equal to 18. Now what can we do? Divide by 2. And we get x is equal to 9. Is that what I needed to get? Yes. So we used our graph to find it, and we have proven it algebraically, and it's also an x is equal to a value of 9 if my y value is -2. Okay. So both ways are going to help us. Okay. So I want you to try one. I want you to try number 3. So find the graph when f of x equals -12. Remember, that's exactly what we just did, but now it's -12. Label that point on the graph, and then I want you to do number 4, actually solve for x and make sure your answers match each other. All right, so you do 3 and 4. All right, Caleb, you said you got it. And we're back. You're coming back to me. When y is -12, Caleb, what did you get for your x value? -6. Good. So we drew our dot and we labeled it -6, -12. Number 4, I wanted you to show the math. Okay? You got me? All right, tell me what to do.
So right now, I already add 8.
Mm-hmm.
No. And then adding negative 2/3 equals negative 12.
Okay.
Times and not being about 3. And then negative 4 by 3.
Mm-hmm.
And then I'll be cancel out the 2 ends. And then go with 12 ends. Negative 12. Yeah, no, negative 12.
Negative 12. There you go.
And then you get 5 by 2. Divide by negative 2.
There you go. Good. So our answers match. Good. So number 2 and number 4 wanted you to show the work to prove it. Okay. Graphs are awesome, but graphs are really assumptions. Okay. I know you like them, but they are assumptions. When we solve using the function, that's proving that our assumption is true. Because how can you tell the difference between negative 6 and negative 6.1 on a graph, right? Or negative 6.02, right? So graphs, whenever you pull a point from a graph, you are always doing like your best guess, you're assuming. Okay, so are we ready to put some like words to this? This is going to help you, page 79, 1 through 4 is what we just did, okay? The back, page 80, is going to be more like what we're about to do. All right, from 2000 to 2020, a World Health Organization collected data on the percentage of a country's population that had access to safe drinking water. The function W of t equals 0.5 t plus 47. It models the percentage of the population in Guatemala that has safe drinking water, where t is the number of years since 2000. T is the number of years since 2000, all right? And W is the percentage of the population that has access. Okay, so T is number of years. W is the percentage of the population. So according to my function right here, T is my input, so this is representing our X. So X equals T equals years since 2000. W of T is representing the output, so that's the Y. That's the percent with access to the water. Do we see how I kind of read that and figured that out? When I speak my thinking out loud, does that make sense? Okay. Let's talk about it. Why? Explain why the values of T should have a constraint. Constraints were yesterday. Constraints are rules, are limitations. What limitations should we have on the years? What constraint do we have on T? And T is my years. So what limit do I have with what years we're looking at? Something about 2000, yeah. We can't go below 2000, right? What else? So T has to definitely be bigger than or equal to 0, right? Because 0 is showing the year 2000. Was there a limit on where they stopped? Or did they go on forever? Read the very first part. Yeah, from 2000 to 2020, right? So how far are they going? They're only going up to 20. So T has to be bigger than 0, and it has to be less than or equal to 20. You can write it like this, or you can write it like this. The time, the years, is in between 0 and 20 years since the year 2000, okay? So those are two different ways to write the same thing. Okay, so it told me the time range of what we're talking about here. All right, write the constraints of the values of T using set builder notation. That was yesterday. That was also a week ago. There you go. Squiggle lines. What variable are we using? Oh, we're not using x this time yet. We're going to use t. Then what? Not yet. The dots. And then the inequality. So if you want to put the first part, y'all, I'm talking, so you should not be. You can put t is greater than 20 and t is less than 20, or you can do it where they're together. Mathematically, I like this one the best because it shows that your time is literally in between 0 and 20 years. Like that. Okay. Number 3 wants you to write the constraint of the values of W using our set builder notation. Okay, so let's kind of have to be a 2-in-1. We got to figure out what the constraint is, right? Before we put it in set builder. So we know set builder, we're going to use W, right? But I don't know what to fill in with yet. So let's talk about it. What is our constraint? It is % of people with access to the water. Okay. So is there limits to percentages? How low can we go with percent? We can go as low as 0, and technically, how high can we go with percent? 100, right? Wouldn't 100% mean everybody? Yeah. So here, we can be in between 0 and 100, technically. So that's the constraint. If we're talking about percents, we can always go as low as 0 and as high as 100. They didn't tell me anything about where we're starting, where we're going, anything like that. Technically, those are all viable when talking about percentages.
So you throw what you put right there.
Yeah. So that's what's going to help me complete my set builder notation. This is set builder notation. Okay.
Jeff, why you threatening to hit me?
Questions about this one before we move on? There's more to it. 100 represents everybody. Okay. We are going to graph the function using the constraints we just did. Okay, and then we're going to use that to help us on the other ones. Here we go, graph the functions. From 6 and 7, that should definitely say from 1 and 2. Don't know why that says that. Okay. So let's graph. We are graphing W of t. Whoop. What 2 points always help me graph? What 2 key features? My y-intercept and my x-intercept, yeah? So how do we find the y-intercept? Make x equal 0, right? We have this function. I know you don't have a lot of space. We have this function, W of t equals 0.5t plus 47. Does this function already show you where it's starting? Where? 47. Good. This is already showing you that we're going to begin at a y-intercept of 47. Okay, so I'm going to go over here on my graph. Here are my y's. I'm going to find 47, 45, 46, 47. It is very small, but it is there. Okay. Do we have a slope according to our equation? Yeah, it's 0.5t. What fraction is that? For 1/2. I mean, dang it, I just gave it to you. For 0.5, 0.5 is the same thing as 1/2, right? So we could use the slope of up 1 and over 2. Okay, 0.5 is the same thing as 1/2. So if I go up 1 and over 2, I mean, it's going to be small, but it's there. Are we going to have an x-intercept? No, so it's not really going to help me to graph that one. Graph it this time, okay? Because my slope is positive, so we're going up, which is good. That means more people have access to water. So it's either up 1 over 2 Up 1 over 2 is going to be real. Up 1 over 2, up 1 over 2. So it's slowly increasing. Up 1 over 2. I'm going to show you like the last. Up 1 over 2, up 1 over 2. Okay, that if the last point on the graph, when you go all the way to the end, is at the y value of 66. So the last point we can put on here has a y value of 66. 36, 37, 38. This is 38, 66. Oop, we get plug in. Like that. All right, so how come I didn't let my line keep going backwards? We can't have negative time, right? Okay. Someone tell me what I did wrong. I made a mistake and no one said anything. So to graph it in the context.
You didn't graph a fixed line.
I mean, I graphed the line the right way, but what were my constraints? My percentages are between 0 and 100. What are my years? I should have stopped where? I should have stopped at 20. That is not a straight line. We're going to try that again. So if I'm only graphing within the context, okay, then this line needs to stop at 20. So this is 20. What's that value? 57, I believe. Okay. Okay, so I don't go backwards because we're not going backwards in time, but I also shouldn't keep going past 20 because we already said my time is only in between the first 20 years. All right, let's answer some questions. Use the graph to find the solution. W of t equals 55. Is 55 an input or an output, Jamari? Exactly. Is 55 an input or an output? Output. Good. Is that my x or my y? Yes, it's my y. So it wants to know if I know that y equals 55, what x does that match up with according to my graph? So if my y is 55, it looks, nope, that's too far. It looks about right here. $55. Yeah, so what x value is that? Looks like it's 17. Okay, so again, graphs, they're sometimes hard to see, right? So we said, I think it's 17. Maybe it's 17. Let's do the actual work with the equations in number 6 to see if it actually is, all right? So they already have the equation equal to 55. Tell me what to do first. I have 0.5t plus 47 equals 55. Tell me what to do first. Subtract 47. Thank you. So now I have 0.5t. Thank you. Equals 8. Then what? Divide by 0.5. What's our answer? It's 16. It's 16. Yeah. It is 16. Okay. So again, graphs are hard to read. Technically, it's this guy right here. That's why we have to use math to prove it. Okay. Because sometimes it's so close, it's hard to tell. Okay. So it should be 16. Okay. Okay. Questions about page 2 at all? Okay.